Hello and welcome. My name is Rafał Jasiński, and today I'm going to tell you about the projects we have done with one of our customers. I am a senior business analyst at PGS Software. At PGS, I work mostly on projects related to machine learning and cloud technologies. In my career, I worked in projects for clients for industries like telecommunications, insurance, and payment services. And today I'm going to tell you about one of the projects for a client from the payment services industry. Let me show you the slides. Okay, fraud detection is a complex domain. So as machine learning, when we combine those two, it is easy to assume that the development of the solution will be an enormous endeavor. Today I'm going to tell you how did we manage to build a production solution in just 6 months. It all started in 2019 with the cloud consulting services. Our client is a payment service provider from UK. They provide services for merchants from all over the world. They reached the moment when their development team and technologies they use stopped keeping up with the business needs. As a result, companies started to struggling with competitors that were able to release new features. In order to change that, they decided to increase agility of the development by introducing modern development approaches and to move their solutions to the cloud. We started our cooperation with Cloud Adoption Workshop. During the workshop and weeks after it, our solution architects help client to develop cloud adoption strategy. And in the course of next month, PGS engineers work together with client's development team on migrating their on-premise solutions to AWS infrastructure. Migration and improvements in development process resulted in quite significant reduction of the development cycle from 6 months to the 6 weeks. In next months, our team started re-architecting their monolithic payment gateway and developed new services for the client. Over time, our team gained a good understanding of client's business and built trust. We became true tech partner for the company. As a result, PGS team started an initiative to build fraud detection POC based on machine learning, and the POC evolved into production software in the end. And that's what I'm going to tell you about today. But before we jump into the details of the project, let's recap a few concepts related to fraud detection. No matter the technology, fraud detection is a classification problem. So solution performs assessment of the transaction and calculates probability of a score of transaction falling into one of the categories. When score is below the set threshold, transaction is considered legitimate. But once the score exceeds the threshold, transaction is declined as a fraud. First type of detection of fraud detection solutions are those using business rules engine. They are present on the market for quite some time. The problem with them is that those solutions check transaction against set of static business rules, which have to be manually configured. More modern approach to fraud detection is machine learning. The main principle remains the same. So models assess transaction and calculate probability of transaction being fraudulent. When probability exceeds the threshold value, it is declined as a fraud. Opposite to the business rules engines, machine learning models don't require explicit instructions how to perform the task. In the process of training, models learn on historical data how to perform the task we want them to do. It means that they can use much more data related to the transaction and perform the classification better. That's one benefit. Additional benefit is that they are much easier to scale and adapt to new patterns in data. You just have to train the model and deploy it to the production, and that's it. Let's briefly discuss how the results of classification look like. processed transactions fall into one of 4 categories. Let's start with transactions that are classified as frauds. They are in the circle on this diagram. And in this group, we have true positives. So these are frauds that were correctly identified by our solution. On the other hand, we have false positives. So these are legitimate transactions that were classified as frauds. We don't want that to happen because we are declining legitimate payments. And outside in the rectangle, we have true negatives. These are legitimate transactions and our solution managed to identify them as such, and false negatives. So these are transactions that were classified as legitimate, but in reality, they were frauds. Performance of fraud detection solution can be depicted on the diagram called ROC curve. We see right here. On the x-axis, we have the false positive rate. It is the fraction of all legitimate payments that are incorrectly blocked as frauds. On the y-axis, there is a true positives rate. It is the fraction of all frauds that were caught by the solution. Shape of the curve depends on the solution quality. So the closer it is to the top left corner, the better. The reason for that is that in such case, solution detects a lot of fraudulent transactions without blocking too many legitimate ones. But the actual performance of the solution depends on the business decisions. KPI for most of the fraud teams is the rate of detected frauds. There is the strong incentive to avoid fraud at any cost, and decline rates are not necessarily monitored. In such risk-averse scenario, solution can be configured in a way to provide very high rate of detected frauds, but it comes at the cost of high false declines rate. This is the top right corner of the diagram, the dot you can see there. In reality, 40 to 80% of declined orders are actually legitimate. It means companies are losing money because of the fraud detection. And let's go through the simple example to show how it works. We have a company that makes $100 million a year in revenue, and they decline 2.5% of their orders because they consider it fraudulent. It appears that 66% of those declined orders are legitimate. It means that a company is losing 1.6 million a year by declining legitimate orders. So fraud detection done in the wrong way can actually harm your business. Risk aversion is one of the challenges related to the fraud detection. Other common challenges are problems with scalability and adaptability of rule-based engine solutions, problem with usage of the unstructured data available right now to solutions, and of course, human errors and biases. People are wanting to avoid frauds at any cost, which results in very high false declines rates. As you might expect it, solution to these challenges is custom fraud detection system that uses machine learning. It ticks all the boxes. It is developed especially for your business scenarios. It is enriched with all the data you have available, and it can be adapted over time to the new payment scenarios and behaviors that happen in your business. But when you hear custom solution, you probably think it will take years to develop such thing and it will cost a fortune. But it doesn't have to be the case if you take the right approach, and that's what we did. There were two major decisions that enabled us to move fast. First one was using cloud services. And there are two main benefits of it. First of all, very low entry barrier. Traditionally, in order to run a data project, you would have to make huge upfront investment into hardware. With cloud, you just provide credit card details and you're good to go. And you pay only for the actual resources you used. So it's great for experimentation. Second benefit is that all of the cloud providers offer managed services like AWS SageMaker. They require very little configuration before development team can use them. So it is possible to start working on the task almost from day one. Another important decision was to follow MLOps practice. When we were designing the solution, we had continuous improvements and development in mind. In order to ensure that we followed MLOps, which is similar to DevOps from the development world, but is focused on the process of machine learning models training and deployment. MLOps looks to increase automation and improve the quality of production machine learning models. As a result, it is possible to deploy new models in minutes instead of hours. And here you can see the timeline of our project. It all started with 2 months long proof of concept. During this proof of concept, a team of our data engineers and data scientists worked on the sample of data we received from the client and developed machine learning model that was detecting fraudulent transactions. After that, in the first release, we deployed the POC solution to the production. We retrained the models with all the data that was available and automated data collection for the model. In next month, our team developed solution monitoring and dashboards for that, and improved performance of the models for new types of merchants. And in the final release, full MLOps pipeline was ready, and our team introduced automated model retraining based on model drift. So model was monitored, and every time its performance fell below the threshold, it was automatically retrained with new data. So it was always as accurate as possible. Just to summarize, it is possible to create a custom fraud detection solution quickly and efficiently if you take the right approach. And cloud platforms significantly help to reduce development time and required upfront investment. MLOps, as a practice, is an enabler for repeatable, high-quality machine learning development process, which means continuous development and continuous improvements are very easy and time efficient. So your model can evolve over time and always be as accurate as possible. That concludes the presentation. I hope it was valuable to you. If you want to learn more or discuss any machine learning or cloud-related topics, feel free to contact me. Thank you.